So I guess most of us have been in this situation. We work with someone and that someone has a big problem because they have this big legacy monolith or whatever that they are no longer, maybe a distributed monolith that they are no longer able to evolve, maintain, and for many reasons is not, nobody's happy with it. And so the usual thing, the first thing that everybody thinks about is rewriting it. But rewrites are very expensive and risky. So there's many things that conspire to make rewrites difficult. And the number one thing is that they take a lot more time and cost than we would like, and a lot more time and cost than we foresee, even if we know that they will take more time and cost than we foresee. So what if the legacy code was not that bad? What if we could take it and make it viable, workable, maintainable again? So this is what I want to talk about today. And I will start from two real stories that happened that I was involved in. Then I will talk about what is port and mend and what it implies for technical people and non-technical people, because the decision to rewrite or not rewrite is a strategic one that everybody involved should have a way to think about and to have a part in the decision. So, briefly about me, I've been working modernizing old software basically most of the time in my professional career. And yeah, and let's dive in. So let's first think about legacy. Legacy should be respected because if the client is there and is asking us to help, it's because they are successful, they have money, and that money most likely comes because this legacy system is working and is bringing money in and day out. So we should not despise this work. It was what made the client successful. On the other hand, we'll know that this code can be difficult to maintain and could have a ton of problems. So let's start with the stories. This is a rolling mill. It's in southern Italy. It's the second largest rolling mill in Europe, or at least it was 20 years ago. And I was involved in this porting enterprise. So what the client was running, so let me explain what goes on here. So from this side comes a 40, no, let's say a 20-ton steel slab that is progressively smashed and rolled into a stripe of hot steel. And these towers here are 5 meters tall, to give you an idea of how big this plant is. And there are 4 of these. And after the 4 how do you call them, rolls, you have to wind the coil, wind the strip into a coil, and the temperature at winding must be within a certain range, otherwise you have a non-conforming piece and you have to rework it, and it's a lot of money lost. So you spray water on the hot steel, just how much is needed to bring the steel to the desired temperature. So the software we're talking about controls the faucets that open and close the water, and gets some information from pyrometers, which are thermometers that can take the temperature of hot steel. And it's a basic feedback system, right? So this was a very large Fortran program that ran on a VAX computer, and the VAX it was running in was crumbling, literally. One night we were out for dinner with the people responsible for the plant, and they had a phone call that the hard disk crashed. So they had only one remaining spare hard disk. So they replaced it, found that the backup didn't work, and then they found the backup of 4 years ago, and the developer working with the plant reapplied all the patches by memory. That's human version control for you. So as you can see, this was a difficult situation. So what did we do? We set up a parallel plant. So we had a PC where we ported the Fortran code. We had a .NET Fortran compiler, and we basically got a duplicate of the messages coming from the plant. So whenever a strip of metal was coming here, we were following what was happening here on debugging basically the Fortran code. Fortran code crashed very often because it was written with a naive concurrency. They didn't apply proper primitives for concurrency control, so there were a lot of race conditions. But the old version worked, so our goal was to make the ported version work too. And also we had a nuanced strategy. So not everything was ported. The reporting was rewritten completely because the reports needed to work with the modern laser printers, not the old line printers. And the database also was no longer a file system, but we made a bridge to SQL Server. But the core logic was ported to Fortran.net. Now, this is the interesting bit that we were able, a team of 4 people, if I remember correctly, we were able to port these in the course of from spring to November. And the client was very happy because they said other competitors of yours, they proposed to rewrite. We didn't want to do that because we knew that a new system would have to be tested, and the testing goes on for a long time and it's very expensive. So, it turned out that, it took enormous patience to go through every race condition. Some of my colleagues were really keen on doing this, so it was not easy, but it was very cost effective. And this started a career of salvaging industrial crumbling code bases for my employer of the time, because you can't imagine how much crumbling hardware and crumbling software is there in industrial plants. Whatever. But then Docebo. So you might have heard of Docebo. It's a company that produces an e-learning system. In Thoughtworks, we use it. Our own internal system is called Campus, and it's based on Docebo. And this company has the main engineering location is in north of Milan. And we had this situation. So basically the old system, simplifying a bit, is a large PHP monolith. The initial plan was to rewrite it to microservices with new micro front ends, micro databases, etc., etc. So this is the usual recipe, if I'm not mistaken, for strangling the old system and rewrite it incrementally. But it turned out to be a lot more expensive and longer than expected, even after this simplification. So at some point, we accepted that we were going to work with the old database through an anti-corruption layer, but it was still quite expensive. So we tried something different. We chose to consider to take parts of the old monolith and port them instead of rewrite them. But first, you need to go to safety. So first, you need to work to remove the danger of outdated PHP. So this old system was PHP 7, which is not supported, and it carries a lot of non-updatable libraries because the modern libraries require PHP 8. So it was a lot of risk in this old code base. It was urgent to rewrite it to something that is supported. So the idea was, let's first remove all this problem with outdated PHP and libraries, and then you can decide if you like it, you keep it this way, or you rewrite it, or you do something more value added. So the legacy was thought to be irrecoverable. It was written with the YII framework version 1, which is notoriously incompatible with version 2, and lots of incompatibilities. And basically, it's very intricate. So it had the notion of separate apps, But when you initialize all of them in the same process, it means that every app pays the cost of initializing all the libraries that belong to other apps. So even though you might not be using the rich text editor, you have to initialize it. If you don't use the, I don't know, the mailing system, you have to initialize it. And this makes every app depend on every library. So we said, let's take one of these apps, put it in a new container, and with the PHP 8, and fix it. Basically, it was a lot of patience here too. So we started to take the index.php, run it. It breaks because it misses one class. Add the class, run it again. It misses another class, add it again. And it took a lot of patience, but eventually we got the first page rendering again. And from there, it was incremental. So basically what we achieved is that by upgrading in place some libraries, by finding substitute for others, by doing not rocket science, but patience-heavy work, we were able to take one part of the monolith and make it independent, relatively independent because it still depended on the large database, but it was a step forward. So working in this way, we were able to port 4 of these libraries, or 5 of these libraries. One stream of work out of 4 worked in this way, and they achieved better than expected speed. So this proved to be a win for our work with this client, and the then CTO appreciated that you have the option of porting in different ways, right? You know, it's one thing to port and mend. It's cheap and fast, but it doesn't give you a lot of improvement, except safety, because this code was now tested, now updatable with proper package manager and so on, or better treatment that gives you more value and but is a lot more expensive. So, any questions about these two experiences before we go on? Yep.
One about.
Wait.
Oh, I'm sorry.
I'm going to give you the microphone.
You didn't expect this.
Yeah, no, I was not prepared.
Okay, so just quickly, a question around your need for being accurate in terms of estimates, etc., because you're comparing against rewrite estimates from other vendors or something along these lines. I'm just curious to know how, if there's any.
Well, this was what our client said here, and we can take their word for this because they knew that when they first implemented the system, it took as much time of development and as much time of testing on the ground. So that's their experience. Now, of course, nobody in this field is doing accurate tests of is this working faster doing this way or that way, because we can't redo the same thing in the lab and have an accurate prediction. But we have the experience. So one stream achieved the 5 modules in 4 months, and another stream achieved 1 module in 1 year. So they were not the same module, but it's a clear indication. Okay, so let's talk a bit about port and mend. So first thing is that first we might think that something is beyond repair, but it might not. So maybe it needs to think outside the box. The box that Docebo was in is that, updating this thing requires updating it all. And we said, no, you can take one module out and update that. And that is significantly simpler than updating everything. And you can work with obsolete technologies, and you can, and that porting is safer and cheaper, usually, when applicable, not always applicable, but when applicable, safer and cheaper. Cool. So, you know about kintsugi. Kintsugi is Japanese art of taking a broken vase and using a gold glue, essentially, I don't know the English word, to fix it together and to honor the fact that it was broken and now it's mended. So it requires a bit of mind shift because many developers are makers. We like to build new things. We like to design the new thing and start from scratch. And of course, it's a lot of fun, but there's also another mindset, the mindset of menders that like incremental progress, that like to see something working well. And these two mindsets is like being introvert or extrovert. You might have a preference given at birth, but you can change it on demand. I mean, I'm an introvert, but I can, now I'm extroverting in front of you. It takes me maybe more energy than it would take a natural extrovert, but it can be done. And I think it's the same with developers. We can learn to appreciate the work of extracting gold from old code. So let's talk a bit about what this means for developers. So I think there's 3 stages we ought to do. One is map. If you heard Shodan and Jonathan presentation this morning, they were big on mapping the existing. So their approach is very extremely sophisticated, I would say, but you can get by with much less. So start by enumerating things. So how many tables do we have? What are they? How big they are? Then how many modules we have? Then map which software modules affect which tables or which columns. And this starts, clearly the map has a different shape depending on your case and your system, but you can start with very simple counting and listing exercises and mapping exercises. And 2 years ago, Sandro Confetti discussed exactly this scenario with a system built on a 4GL that basically had one remaining installation on Earth, and he was able to use a parser found for this 4GL to enumerate all the tables in the columns and map them to the functions in the code. And this is a starting point. And then what you do, you bring safety. So you want to make the system safe to operate. Safe to operate is, mapping can also be done with the help of AI. So this is something that I got the AI to write for me, a Python script that takes the import structure of a Go program and shows you shows it in a graph. Is a graph drawing, and you can get the AI to write similar scripts for you, maybe availing existing parsers. So AI changes the picture for us because it makes much cheaper things that would be more expensive before. And let's not forget that we should be always talking to the people who built the system, those who are still available to us, maybe might be retired and moved on to other jobs. So a big part of mapping the system is mapping the functionality, interviewing retired people, and so on and so forth. Because not all the information is in the code. Then safety, what safety means here. At least these 4 things. You should first have a way to prove that your changes are not breaking anything. So automated tests, possibly at acceptance level. So when you're doing non-regression, acceptance tests are the most valuable because they describe the behavior of the system in terms that a business user can understand and check it in an integrated way. So they give a highest confidence that I understand what the test is trying to prove. And when they fail, I have an understanding that a feature is no longer working as intended. Then you want to have high-level documentation. So detailed documentation is of little use because we can, the best detailed documentation is the code itself. But when the system is 1 million lines of code, you need a map of what's there that tells you where to find things. So again, PodConcise presented this morning is very sophisticated in this. You can get by with something simpler, I mean. Then telemetry from production is very important. So if the system given that the system is probably in production, you want to have access to what happens over there. And especially if you change a part of the system, you want to check that it's not doing something weird in production. So looking at telemetry from production with curiosity. So often we have this idea that we have to set alarms so that we don't have to look at production as little as possible, at production information as little as possible. I think that it's valuable to do the opposite. Try to look at data from production telemetry every day to see what's normal and learn things about the system, because when you start observing what the system is actually doing in production, you learn things about the system that are very hard to understand from the code. And finally, you want to have a fast local development environment. This is a sore point in many legacy systems, but if you can have it, that enables a lot of fast iteration. So find a way to run the system in your local and be able to make changes and run it in your local. And then we should be availing artificial intelligence. Now, artificial intelligence has become extremely powerful in explaining how the system works, documenting, and answering questions about the system. So it's very powerful when you give the AI an overview of how the system works and then ask questions, because it's much faster in going in the code base and finding the things that we are curious about. And writing missing tests, it works very well. Take something, give it an example test and say, write all the missing tests. This works very well because first you set the tone on how the test should be written. Should you use mocks or should not you use mocks? It depends on what you decide is the good way in your context. Give an example and then the AI will do it in the same style as you propose. And you can also discuss refactoring. It's more interesting. So if you say to the AI, hey, refactor this, you're going to get random results, just like you would if you asked a junior programmer new to the system and say, hey, go and do what you feel is right. It's quite random. So you can ask things like, if you were Kent Beck, what would you do here? If you were Eric Evans, what would you do here? So these are very interesting things because you try to get the AI to consider different sources of refactoring, of knowledge, of design experience. What could you achieve by applying design patterns? What can you achieve by looking for duplication? And so this is an example. At some point in Docebo, we were confronted with a CDK file. So CDK is a technology that enables you to create infrastructure in AWS. It's a technology that competes with Terraform, and it's TypeScript. And this was 1,500 lines of code of undocumented CDK. And we were not familiar with technology. So what do you do in this situation? So give the file to the AI and say, can you document what resources this is creating? So this is the good question. We tried a few different other questions before finding the one that gave the most useful results. So iterating with AI is very important. So it gave us a very useful documentation of all the resources that were being created there. And now we could start saying, so what are ways to refactor these? Not refactor, but give me ideas. What could we do here to improve the quality of this code, the readability and understandability of this code? It gave us a number of problems and proposed 3 strategies. And now that we have some clarity on how to proceed, we can choose one or ask more questions. So in an hour of work, we had moved from one incomprehensible single file to an implementation broken down in one file per type of resource and with good documentation. So it would have been very expensive to do otherwise, because especially since we were not expert with the technology. And there's tons of examples of how AI can help with legacy code. Now, let's talk about what non-technical leaders would be interested in here. So the first thing is that we need to understand when it's a good time to do a rewrite, when it's not, or where port and mend or other options are considerable. So many technical organizations push for rewrites more easily than not. So we should be skeptical. We should ask what are the good reasons that prevent a port. Now, good reasons would be, for instance, that the current architecture is hopeless in terms of performance, or maybe the system is not correct, is creating a lot of bugs and problems with. And so when the quality in terms of external quality, we know that internal quality of the legacy system is going to be bad, or we wouldn't be discussing a rewrite. But when the external quality is also bad, then it might be a good idea to rewrite. And sometimes when, for instance, in one case, the legacy system was encumbered, was a proprietary software. So any change required asking for a quote from the vendor. And this was a huge break on innovation. And source code lost, you cannot build it. Also good reasons. Not very good reason when it's hard to change. Okay, now it's hard to change, but we can work and make it easier to change. And out running on dynamic hardware, yeah, we can fix it. Usually we can find an equivalent compiler for new hardware, and the system is ugly. Again, this is not necessarily a good reason. We can work with this. We can incrementally. So the power of refactoring is huge. We shouldn't underestimate how constant incremental changes can do to help improve an existing system. So be skeptical and always consider what. Let's have a plan for a port and mend instead. Now, in any case, you should always be looking for these things. So first of all, safety. So you should ask the technical people to explain how they're making sure they're not breaking the existing system. So in the case of the VAX, we had parallel outputs. So we were comparing the output of the new system, outputs of the old system, and in November, when we were reliably producing the same outputs as the old system, they made the switch. Then you must also ask for incremental value. Any plan that says will work for 18 months and then you'll be golden is a failure. So we need to be able to give the client some improvement, some value earlier than that, within 3 months at most. So take the worst part of the system, the part that the clients, the customers complain the most about, and do something about it. And then we should have clarity of where's the map and what we will do about each part of the map. What's the strategy for each? Rewrite, port. And then if you have evidence that all these things are being taken care of, then you know that your technical organization is likely doing a decent job. Okay? So that's it. I've been a bit fast, but I left room for questions. So, cheaper and safer, usually, in my experience, has always been cheaper and safer than rewriting. And mindset, yes, you must learn to appreciate old stuff. Don't be dismissive of legacy systems, legacy technology, legacy everything, because people did their best to build the legacy system, and we should honor the effort. Then, yeah, preparation is key. Test, telemetry, observability, and so on. And be skilled at using AI. Now, the one thing, so 99% of the posts on LinkedIn that say, haha, the AI is stupid, it does stupid things, in fact, are usually people are prompting badly. So prompting the AI takes skill. It seems easy because, hey, I just write English, but it's not that easy to get good results with high likelihood. It's still random. So it's still a bit of a slot machine every time, but it's a slot machine you can hack. So you can improve your chances to hit jackpot more often. So learn how to use the AI effectively. It's a matter of skill. It's a matter also of imagination. So given that you express what you want in English, I guess there's so many ideas that nobody has had yet or not published yet on how to be creative and in getting help from AI. And that's it. Questions?